Thank you all for coming for this first workshop. That's so cool, and I hope you enjoyed that. Let's start. Actually, this is the first workshop with our great path. The culmination of that path is a hackathon, which names AI for All. At this hackathon, we solve some topics related to charities. At the first workshop, which name is AI Soup, we are talk about different tools and solutions for interacting with an AI context. First of all, let me present myself. I'm Dmitry. I'm a student from 42 London. I'm really passionate about future with an artificial intelligence and possibilities. For me, artificial intelligence is another one great tool, which not just a black box. We can use it to solve our daily problems, our business problems. So let's see where we can start. Let me share the whole screen. Okay, this is our repository. I'll send link to the chat. And also for those who see this video with a recording, it's possible to take this link with this QR code. I'll show it from the beginning. So I'll open the repository and I'll show how it works. For working with this repository, we need an AnthropicAPI key. So this is the first thing we need. And it's possible to grab from the console.anthropic.com. So if you don't register here, please feel free to go through the link and then get an API key and then create it. And then I'll show where it's possible to paste it. Now let's go through the project. Here we have our first script. Let's take a look at this, setup.sh. For those people who never write with a Python, who don't know how the virtual environment work, this solution is ready to go. You just start this script with zsh or bash. So where we start, we open our terminal and /setup.sh and enter. So I already have .env file, and I'll show you what to paste inside of that. And here, what we see here, we installed a bunch of libraries which we used today. So don't be scared about that. All the libraries are located in requirements.txt file. So here you can see the whole stuff that we use today. Yeah, let's wait until all the libraries downloaded. And also, I want to show you .env example. We just set up .sh, just copy the .env example to .env file. Here we have 3 API keys, which we use today. Actually, Anthropic API key, we just put the string that we copied from our website here. And about evidently API keys and evidently team ID, we talk about that later. This is our last Jupyter notebook, and if we have enough time, we go through that. Let's talk about the structure of our repository. Here we have course, which contains all the Jupyter notebooks. We go through them. Also, we have folder files, which contains a couple of images, one PDF file, and a couple of texts. Today we work with them. So let's start with just 2 rectangles. And let's name the first rectangle query, which means our question, right? We use that for asking large language model about anything. Here we have large language model. Call it through API. So in general, how our first pipeline works, we just send the query through API to large language model. So let's do that. Open the 0 introduction to RAG. Our workshop mostly focus on Retrieval-Augmented Generation. Actually, our number 0 Jupyter notebook are focusing about What is Retrieval-Augmented Generation? Let's at first just send the query to go through the theoretical part. So here, load the .env file into our Jupyter notebook, get the API key, which is located in .env file. This button or Control-Enter, we can run the function. And here we see with the print the result, our string, our API key. So, and here is our first interaction with an API, with an Anthropic API. So how it works? We use Anthropic as a library, which under the hood have everything which allows us to connect to their server. We create an instance of Anthropic with name client, put here API key, and then create the user prompt, which means query our question. And then we create a response with the client.messages.create and put our user prompt in a message here. And basically, that's the main easiest thing to know, how to send the user prompt to an API. But we see here a lot of other things. So let's take a look at them closer. First of all, Claude provides different models. And Haiku, Claude 3 Haiku, is lightweight and fastest model from Claude for interacting with the small bunches of text. So for our tutorial, it's a great solution. In a different context, we should use actually different types of models with a bigger amount of context or with a more efficient system. It's actually our system message, which we can provide with our user prompt query, but the difference is the system prompt is going through all our conversation. Like we can talk to our assistant that you're a helpful assistant. If you don't know the answer, please respond with I don't know. And then with this context, we send user prompt. Let's do that. So our question is, what is the current date, right? And pretty nice answer from the Claude is, I don't have access to the current time. As an AI assistant, I don't have built-in calendar or ability to check the date. This model don't have access to the internet. And now let's come back to the beginning, to the introduction to RAG. So with this technology, we can solve that problem and give context of current time to our conversation and know the current date and the current time. So what stay behind the RAG? First of all is retrieve. Like we paste our knowledge base, which related to some knowledge area that we want to work on. Then ask something, take from the database augmented data, and then generate with it. We take the data from our knowledge base and then augmented it with different aspects which detailize the answer or the result we need. And generate as the final component where we have the final response, where machine learning model helps us to like take the chunks of text actually and represent them in efficient way we need, so we can control that. This is basically what the RAG means. Here in the text, then you can dive more through detailed aspects. And please take a look at Anthropic Cookbook, which contains a lot of Jupyter notebooks with the different areas of situations where you can find the solution you want. And also for detailed API reference, you can go through this link and see the detailed, like all the possibilities of the Anthropic API, because there are a lot of things you can do with it. Here, another Jupyter notebooks and another links like related to the context, and go through it, read all of them, and you understand basically how Anthropic work, what the possibilities are in more detailed way. Here we go through like our more focused curve, more related to work with the text, but also we work a little bit with images. So let's come back to our theme about the current date. Here we have new ingredient, a date from the datetime. We have our user prompt, which is here, and we make this user prompt more wider. Why? Because we add new context here, like the current date is, and we return the result of the function date today. And plus, we paste the string, what is the current date. So let's see the result. Ta-da! This is a result from the function. This is a result from the LLM. So this is our first RAG, the most tiniest and the most easiest RAG we can build. Let's add some custom text context. What we have here. Actually, in our text site, we have different files with different articles from Mixmag. Mixmag is like music journal. One of the article contains the news about the labyrinth synthesizer. And I just copy the one sentence from this article and put it here. So here it might be the whole article, right? So then we increase the context and you will see how it worked then, but this is the most easiest way to present you the context. And now it's just one sentence. And how it works under the hood, if we go more in detailed and professional way. We write the prompt, the custom prompt, which is focused on specific situation. Let's take a look at this closer. You have been tasked with helping us to answer the following query. And in text query, we put our actually user query. So to use text in Anthropic is a very nice way to show the specific areas that LLM should be focused on. So this is the really nice and useful way. Here we identify that we have some question, and then we prompt that you have access to the following documents which are meant to provide context as you answer the query. And we put with the tag documents our context, which is now just one sentence. And then we say, please remain faithful to the underlying context and only deviate from it if you are 100% sure that you know the answer already. Answer question now and avoid providing preamble such as here's the answer. So we show how we want to see the answer from the question. And we put all this prompt, all the stuff we have here, which is include the query, which is include the context, to the user prompt. And let's run it. So our context that labyrinth is available for now for £599. Our LLM answer us with £599. But sometimes LLM just not use our rules that we ask to. This is all about prompt engineering. For every specific area that you want to solve, you should first of all create the prompt which is work for you and your context actually. And then you should test it. And actually at this point, to work with large language models through API monitoring, which we are looking at the end of our workshop, is a very helpful thing to identify. Actually, we can track which answers are right, which answers are not right. The results contains the specific letters or not, and bunch of other things. So the conclusion, we create a small database just with one sentence. We augment the information with a specific prompt. We use API call to LLM with the whole prompt to generate a response. This is our first touch with large language model in context of RAG. So thank you for your question, guys. Now let's get through the next file, which is actually add to our context something new. So we have a query, right? We have an LLM API, but also we have a database. with our specific area of knowledge. It might be articles, it might be news, it might be images. What pipeline we are looking for now? We have a database and we have actually, like, let me write it more details. We have some files. So we want to put the files into our database. Here we look at new tools, embedding functions. So vector database, what's the difference between relational database and vector database actually? We know the relational database. Let's talk, it looks like Excel table or Sheets table, right? We have the columns and rows and the data in each cell in our table. Actually, we store some strings here, data based on strings. The vector database, actually let's add this word here. Store vector representations of files which we are put to this vector database. Embedding functions allows us to do that. Embedding function on input take the string or image and convert it to the vector representation of data. So this is the first thing. Then we have our query. We send our query to the database. Query converted, let's make it like that. Query converted to the vector representation with the embedding function. And then vector database return to us augment result. Actually, we just like see there some chunks of text which are related to the query. So how it works? In vector database, we store a vector representation of our data. When we send the query, we convert it to the vector representation, and then in vector database, we compare those vector representations. So we find the closest vector related to our query and return the closest results of vectors, which are chunks of the files that we download to the vector database as a result. So, and then with this augment result, we have like another one part. We send our query again, and here we have query. So, and imagine we have this context of our query and augment result, and then we send all of that to our large language model. And then we have a response which is related to our data actually stored on our vector database. Is there any questions like right now at this point? Is the vector database goal to create our augmented system context? Yes. We put the data, like for example, we put the PDF file. We today work with it. We put our PDF file. We convert it to the strings and then to the vector representation. And then we query through that and ask a specific areas of knowledge about the PDF file we have. So here our next file. Let's just like load again our API key and call the client. .env is the file where contains your private API keys for interacting with the services. It's like the common side of representation.env file. In our context, we, with the setup sh, we copy .env.example to .env file, and then in .env file, we put the AnthropicAPI key, and then we can work with Jupyter notebooks here. So when we call the load .env with this path, we call the .env file, and we ask, is there any AnthropicAPI keys in .env? If it's yes, it returns us the string with this key. we have new concept of ChromaDB, of our vector database. We create a collection with our custom name, and here we use the embedding function. So again, about the embedding functions, let's talk about them more detailed. Embedding function convert the string or image to the vector representation of this data. And each embedding function have bunch of things under the hood, but let's now focus on just two of them. First is a context length. How many data we can put at this function to represent data in efficient way. So each embedding function, each embedding solution have their own limitations, like the maximum of tokens, which is provided correctly within a vector representation. We use all Mini LM L6 V2, which is work perfectly with the simple text, which is work perfectly actually on our personal computers. We have a limitation with just 256 tokens. Then when we work with the text, we split those texts until less than 256 chars, and then put those chunks to the vector database through that function. So the dimension, the embedding dimension, this is 384. Let's look at that as a resolution of your monitor. More dimension, more embedding dimension we have, more detailed and specific representation of our data that we put inside of this vector, we can query through the database. Here we can take a look at the partner of Anthropic Voyage, and we can see the different embedding models. Actually, let me open that. Let's just take a look at specific area here, the available models. Let me make it more comfortable to read. So let's see, here we have context length 16,000 tokens, and the embedding dimension 1,536. That is huge, right? And for working with this model, you should create another one API call to convert data to vector representation and then put it into the vector database. But we don't do that today. Don't be scared. I just want to show you that this is the new thing which you can improve in a specific situation you want to solve. For example, if you work with the code, maybe it's better to use this model because it's trained for working with the code. But if you work in a general with the text, maybe it might be okay to use just Voyage 2. Try it actually in your context and test it, and you will see you can compare the different results. So that's about the embedding. Let's come back to our case. So here, what we do, we actually import our embedding function, all Mini LM L6 V2, create the name of the collection. Let's name it my first collection, and then create an instance of our vector database. And so here we create it. So here we create the instance of that, and here we declare the collection of that we're working on next. Here we put our name, and here we put the embedding function which we use to convert our data to vector representation and to put that inside of the vector database. One thing I want to highlight: if you start working with a database and you declare one function, you should use the same function in this vector database. So you don't allow to change the embedding function, because when you query the collection and want to find the data related to your query, the embedding dimension, which here related to 384, should be the same for all data contains in the database. So let's create it. Persistent client, it's more for debugging side or for educational side that we use. In production area, we mostly use HTTPS client for sure to securely connect to the database. This instance It's great. Actually, the database contains in our course folder, and we can access to that. So we can like dive into that and take a look at that. Oh yeah. So this is the folder, and this is our instance of the ChromaDB. Just like we can go through that and take a look at all tables here and control like what we do next. So for seeing all of that features, if you in the VS Code tells you like install the SQLite extension to look at the database like me. If you don't have this message, let me just highlight the SQLite. This one. SQLite Viewer. So it allows you to just go through the database and take a look at each section. It's really nice for debugging and for understanding what's actually going on there. Let's come back. So we have our instance, which contains the bunch of things inside. We work with the text, and we want to understand how to load the text and how to split it into the chunks and then put into the database. So this just like simple function allows us to load TXT files from the direction path. We just put the link where our TXT file is located, and we have an array of our documents. So let's do that. Actually, everyone who fetched the repository in TXT file have this beautiful, very nice copied and pasted TXT files, which we are working on here. So what we do with our function, we just like take all these TXT files and put them into one array. Here we go. 5 files loaded, and those files are represented like we have an array of objects, which is text, means, and we see the text. And actually, if you're new to Jupyter Notebook, you can click here to scrollable element, and we can scroll through all the print from our code path. So like if you don't see the whole print, you can just like click the button and see all of them. And second interesting and useful trick is click here on 3 dots and clear cell outputs to make your Jupyter Notebook cleaner. So here we split text into chunks. This is the article like advanced chunk techniques, because this is like another one ingredient in our soup should be specific on your area of solving problem. Because if you work with the different types of documents, they are different, but maybe they have some similar parts, and you can write your own parser in a way which works better for you. And here you can take a look at those techniques, like how to. Here is a open source library. I don't use that because I decided to use just a simple text chunk. Here you can take a look at the library which can convert from PDF to text, and from the other from HTML to text, and from other documents, types of documents to text. Just like take a look at that if you have enough time. But here we work with a simple function, just split text. What we do here, we put here text as a string. Also, we put inside chunk size. Chunk size is our amount of characters which we put inside of the embedding function. So our maximum is 256. Let's put that. And chunk overlap. This is the interesting part. Imagine you have 2 chunks which are close to each other. Overlap shows you the same amount of characters with this amount of numbers. I'll show you in a bit, but I think 200 is too much. Let's make it just 20. And you will see like how the overlap cover the same data between 2 chunks. Why we need that? Actually, you like see this input for the function in every function for splitting text, because when you chunk in the text, the meaning of chunk might be not enough at just one chunk. And if you have this some overlap between 2 chunks, when you go through vector database, database might grab the closest chunk to grab the data which you actually need to have in the end to send it to LLM and to have the right answer, right? That's why chunking overlap is useful. And actually with this like 2 parameters, actually for having great results in your context. Yeah, so, and here we have another one. So here we have actually like our result, like array of chunks. Here we make chunks in what way? We take a file and we enumerate all the files we have. Like we have their IDs. We split at our array of texts just text inside of objects, and we have the chunks. And then we create an object ID with the file ID and with the chunk ID. So in one file, it might be like 5 or 6 chunks, and it's better to organize it like that. And in text, we actually have the chunk of the text. So let's see how it works. So we split all our files in txt folder into 43 chunks. And here I just like print the 13 chunk, which is 1 defis 5. So here we have just like one chunk of the file. It looks like that. And the last thing we close to that abstracted to ChromaDB. So we take our chunks and absort them with an IDs and chunk as a document to our vector database. And with this collection data absort, we convert those chunks to vector representation of data. Let's see. We have 43 documents inside of our collection. And now we close to the query. So now let's query collection. Here a lot of commented stuff around. I'll comment it for you to debug and to understand how everything works. Like for now, let's just like call it and see the result. So what do the query collection? Query collection take the question, it means our query, whatever we have, and number of results. So what does it mean? When we query our database, it returns us some amount of vector representations which related to chunks. And we can control amount of these results as a result. For now, it's 5 chunks. I can change it to 3, for example. Okay, let me call it. And here we have an API response, which is related to our previous file, which have pretty the same thing. We don't focus on that. We just like go through that next. And finally, we can query collection. So what Lego product we have? So we have some article which contains something about the Lego. We send this question to our database. We have relevant chunks. Then we send to the API response our question and relevant chunks and have the answer. Let's see. And here we go. It appears the Lego has produced and considered producing Lego versions of various DJs and music production equipment, including the Technics SL 1020 MK2 turntable. Let's test it. Lego. And we see our result. We can go through the whole answer and we can compare that to our data. So that's the simple rack. If everyone, mostly of you are alive, let's go to the next one. It's way more interesting. So let's take the things under control. And let's start from the theory again. So we have this beauty. And let's add another one thing to our pipeline. Hypothetical document embedding. For me, it's like the most interesting thing in building RAG because it gives you more control under the relevant results you can have. And you can control in a more specific way how the large language model in the end should provide you the answers, and you can take more reliable data from the database, because we can ask in a different way, in a different words, the thing that are contains in a vector database. With hypothetical document embedding, we can add more data actually in the context of our query, put that data into vector database, and have as a result more related data in our context. So how it works? We have our query here. And let's add here another one, rectangle. Which is a augment query. Make it huge. So we have our question, like any of questions, and actually under the hood, it contains the API call to our large language model. But what the idea of that augmented query? We can prompt here, provide a hypothetical answer to the given question. Yeah. So we have this prompt. Large language model returns us provides us some answer, some hypothetical answer of our question. It's hypothetical answer of our query, but it might contain wider amount of details and information hypothetically related to our query, and we can send it to our database to find the related data for sure with our query. And now we have two inputs to our database, the hypothetical answer and the query we have. And we send all of that to our vector database. We have as a result to this section, actually hypothetically and practically, more related data, more relevant chunks, all of that. So let's start from the beginning. Here are some theoretical stuff. Here are tools we use, Anthropic and ChromaDB. And again, we do the same, import the API key, create the new collection. So actually we created here our instance of database, but we hide the collection. We do the same, we take all of texts, split them. Let's go through it faster. Put them into that collection. We have the new collection. And here's some theoretical stuff that I represent you with the Xcali draw. And here's some use cases. So let's go next. So this is the augment query, how it looks like. We add the specific prompt, make a user prompt with the question we have and with a specific prompt, and put it as a message and send it actually. And here we have a query, how much costs synthesizer labyrinth? And let's see. We have an answer that we don't know the specific cost of the labyrinth synthesizer, but hypothetical labyrinth synthesizer could be high-end professional grade analog synthesizer with a complex and extensive feature set, and etc., 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 with another bunch of information that might be at this context, at the context of synthesizer labyrinth. Actually, let's take a look at the file and see, briefly, that this is a new semi-modular synth labyrinth. Actually, semi-modular synth, it's analog synth. So large language model answer us right. It's actually made by Moog. So that's the famous company. Here, another bunch of data. So the hypothetical answer is pretty nice. It's pretty nice to query this article, the labyrinth article, and let's see the result. So here, pretty the same function about query collection, function about API response. So let's call that one. Why I call that every time I go through each file? Because we have our scope of functions which are useful at the next code section. I just go through each code section to make sure that each function related to this context properly and work properly. So, and here we have final result, right? Our final like pipeline. Actually, that is our pipeline. We have a question, tell me how much cost labyrinth. We make an augmented result with it, with a hypothetical answer. Then we put this question with an augmented result to our collection to find the relevant chunks. And then we send those relevant chunks and our question and see the answer. For sure, answer is pretty the same. For you to test like, is it work right or not, you can take a look at other articles here and try to play with them. But next. So for this one, that's it. Actually here, like some helpful utils, which are related to, we can see the list of collections we have here. So we have here hide the collection and my first collection. And with this method call, actually, we can delete the collection with a specific name. So for each Jupyter notebook, if you go from top to the bottom, you can like create collection, work with it, and then delete that with those functions. Let's see how it works. Actually, and yeah, we delete our hide rack collection, and here just my first collection from the 0 point. Is there any questions? So we are at the third of our Jupyter notebook. I hope you are all interested still on that, because now it goes like more interesting, because we are taking a look at multi-modal stuff. So let's come back to our picture. Here we work mostly with strings, right? Just with text. But now we are open new doors to work with images. And here, this part of the workshop are more how to work with images in the database. So let's add an image. So first of all, we have our files, which contains text and images and other stuff. But here we take a look at images. To convert image to the vector, we use embedding function. This type of embedding function should convert the image itself to the vector representation of data, which is associated with the text. So that's the thing. And here we work with technology named Clip. Here you can take a look actually at the paper of the Clip, how it works, what stays behind that. And another one link is about for Chroma documentation, how to work with multi-modal embeddings and datasets. Here we used embedding function, and when we create the collection and we work with a multi-modal, we use the Clip embedding function, which work with the text and images both. We use this function and for text and for images. So at this case, we don't use the previous mini L6v2 embedding function. I just want to mention that. So let's dive in. Let's add all imports. Here we create our another one collection. And here we use two new items. So here we use the embedding function, open clip embedding function, which is here. And we use data image loader, which allows us to actually load the image and show it to us. And here just tiny simple solutions, how to add to collection images. So let's take a look at our file structure. And here we have some images. Here we have image with a cat, image with a dog. And what we do here, we put the links of those images, put the IDs here. And when we edit, what we actually do, we convert those images to the vector representation, but we need to store also those links to show images itself as a result. So let's add them. Here we have just two files. This is more debug function. Here we print the results that we are querying to the database. So it opened eyes like how to interact with the database and this stuff. Here we actually query with a string our collection and print the result. Here we see for sure two images because our number of results are 5. So, and here we see the warning that number of requested results 5 is greater than number of the elements. And that's actually the right warning. Here we see that we query just a dog. And here we see from the debugging function our data. Here we see the distance between our string, which is represented actually in vectors too, as we remember, as we know actually. So we don't have here any metadata. We'll go through that. And here we see the data, which helps us to show the image actually. And why dog is at the first place? Because the distance between word and result for dog is less. That's why it's on the first place. Here 1.457, here 1.620. So let's add more images. What we do here, I add here some famous soup and some metadata for all of them. That's such a cool example. I like that. So let's add that. So here now we have 7 because we have 5 soup images and 2 of pictures with the cat and dog. Here I can query with a specific word which or presented on the image or related to the metadata. Let's take a look at beef at first. So beef contains in borscht. And here we see in ingredients in metadata beef. Let's check it out fish and see which soups are related closely to fish. Kulinshink contains fish, we see that. But also we see the not relevant result because this image, this is not a real soup. The ingredients are not real. I want to highlight that point. So this answer is not correct. I'll show how to prevent these results too. So let's go next. This result with the shrimps. Okay, let's see the shrimp. Let's query with that. Perfect, it worked. So we can query with the strings and have as a result images. But what if I want to query specific ingredient, Anthropic, which is related to one cool soup, AI soup? And we see here that the result is actually dramatically negative. It's like first and second and third images are not just like the fourth image, which contains Anthropic, have a right answer. Actually, how to prevent those issues and how to make your queries more direct and more relevant and more focused, because when you have different types of data and when you have some specific things that are related to specific context, you can add where the query should be located in SOUP, for example. So here is better. We don't have cats and dogs, but we also don't have an AI SOUP, because AI SOUP have category course. And if we go to course and go through that, we see the result. Or we can go with the SOUP, and this expression means equal SOUP. If we use expression NE, which means not equal, it might return the same image. So we just exclude SOUP category and ask to show the relevant answer in our query. So for images, that's actually pretty much it. Is there any questions? Perfect. So let's dive into the last Jupyter Notebook. Here we talk about tracing, how to trace our data. So what it means actually? Why we need that? As you see today, we built such a great picture to actually understand how the different ingredients connected into the pipeline and work together to make things meaningful. But for sure, in most of the cases, it should be better to see the results and to have a statistics about every movement in this pipeline you have, and actually make right decisions to make the answers more efficient, to make the more relevant results of your pipeline. So for doing that, we use tracing. We create a tracing function which take the query, take the augment query as this one, augment query, take the result from the database and shows the main result from the large language model. We see in one row how all the pipeline work and what data in each section actually moved to another section. At this example, I use library, actually product evidently, and one of the tiniest and cool products, Tracely. What it actually do? It connects your code to the cloud service, and you upload query, augmented result, etc., 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 to the database at cloud, and then just with mouse you can create the tests and see what's going on around. So that's like pretty easy. This is the professional library, which contains a huge amount of things. We are looking today at tracing, and then with a documentation and maybe with another one workshop, we can take a look at different tests and how to work with them. So here I add all the imports. Here I add an API keys. Yes. So here we need to add API keys from the Evidently Cloud. So let's log in. API keys, I just briefly show where they're located. So this is the main page. Here in our email, we have a user ID. And also we need to add the team main and take this ID. So what does it mean? It means that we connected with the account I'm logging into, and we put data which we are tracing into this group main, because we can work with the different projects in the different groups. So we can create the different group with a fixed amount of people and work with the data just with them. It's just because of security. For sure, when we have all those keys and IDs, we put them here, import them here. So here we go. Here we have all the keys. Then we just init tracing. So it's like in ChromaDB, we create a database with this name and with this API key and team ID and connect with this link. So yes, we have here the result. For sure, we add the Anthropic API key and client because we use that in our project. Here, we create another one collection for this example, which is RugDB. Here, actually the example. So this example shows us the pipeline, how to take the PDF file, convert each page of the PDF file as an image, send this image through the Anthropic API as an image, grab all text data from that, chunk that, converted chunks to embedding functions, and put them into database, and then we can query through that database. So yeah, that's actually the most interesting pipeline from this workshop, hopefully. Okay, with this function, what we do, we have PDF path, which is a precise zero-shot dense retrieval without relevance labels. This is the great paper. Please read that or query that with this pipeline because it makes sense in our context. I create the temporary directory where I store all the images from the PDF. So with this function, I convert PDF file to JPEG format, optimize it for sure, to the specific folder. So let's take a look. Here our original PDF file, which contains a lot of data. Interesting. Perfect. And here in temp folder on the left side, we can see the temporary folder with all the images. Cool. And then here, that's like a more helper image, which shows us how to send the image with the Anthropic API. With Anthropic API, we send actually image as a base64 string, and we also can work with formats like JPEG, PNG, GIF, and WebP. So that's pretty cool. That's great and useful formats. And here we put actually the string that contains the image. So this is just a helpful function to put the string and the type of image here and like return the whole thing as in one block. And here this function is actually take the image and convert it and send it to the Claude API. Here I use Sonnet with 4096 tokens because we convert the whole A4 page with a text. Here pretty the same functions for splitting, for chunking. This takes 3 minutes because we take 11 or 15 pages and send each page to Anthropic API, wait a long like 4,000 tokens response, then convert those tokens to the chunks and put them into one array. And now if you have any questions, we have actually time for that. Why I choose like this one solution, just like to show all the tools together. I know that it's not a best solution and the great solution, but it shows how all the different aspects of our previous Jupyter notebooks work together. Oh, perfect. We have 178 chunks. Yeah, and then we for sure put all of them to database. It takes more time. And then here pretty the same thing like augment query, query collection, API response. So we go for all of those functions. Finally, we are at the end. We have pretty the same function like we have our query. With what topics from hypothetical document embeddings are presented in paper. We create the hypothetical answer, we send them to the collection with amount of 3 chunks, we take the chunks, then we send the chunks and query to an API, then we have response, and then we return all those data as a result here in tracing function. And for tracing, we just add this decorator, trace event, what this decorator do, it takes the input and output of the function and send it to the cloud. So let's run it 2 times or 3 times. Okay, perfect. Now let's go here. So here we can see in traces here already we have some related data. So here we see the query. Here is our response. Here is our hypothetical answer. And here our chunks, which are coming from the database. So, and with that, actually, this is the data set we have. So here we can see the calls. So we have 3 calls here. So each row, this is each call. And then we go to team, choose our data set, this one, from period. Every 30 minutes, we take a look at text values from our query, our result, our augmented query, and chunks. Take an IDs, add the timestamp, and okay, let's go with the easiest way just to take a look at the database. Go to report. So cool, we have a report. So what we do just without anything, what we can see here. Here we can see the description about our database, number of columns, number of rows, missing values if we have them. But also we can have here timestamp. So if we have different conversations in the time, we can see from which time to which time we focused on this database. Here we can see if we have different services. So actually we can go through and check, for example, from the tracing function result 0, which means the final result, which is the minimum length of the answer, what is the mean length of the text, and which is the max length, and a bunch of other things with a lot of interesting actually stuff. You can go through the documentation of this service and actually take a look. It's easier because you just add data to the cloud and then with mouse play with the data and see how it works. That's it for now. Thank you for being here. If there are any questions related to this topic, I'm happy to answer. Otherwise, I'm done.